So guys, welcome to the channel World of Tech.
सो हेलो गाइस, वेलकम टू द चैनल। आज जो हम प्रॉब्लम सॉल्व कर रहे हैं उसका नाम है थ्री सम प्रॉब्लम। तो एक बार प्रॉब्लम स्टेटमेंट को हम पढ़ लेते हैं। सो प्रॉब्लम स्टेटमेंट कहता है कि गिवन एन एरे एंड अ वैल्यू फाइंड इफ देयर इज अ ट्रिपलेट इन एरे हुज सम इज इक्वल टू द गिवन वैल्यू, व्हिच मींस कि हमारे पास एक पूरा एरे सेट है और हमारे पास एक रिजल्टेंट सम है। व्हाट वी हैव टू फाइंड इज वेदर देयर इज एनी सबसेट ऑफ थ्री नंबर्स सच दैट व्हेन यू ऐड देम टुगेदर द नंबर शुड बी इक्वल टू द टारगेट सम। सो इसके अंदर लाइक व्हेनेवर यू आर टैकलिंग सच प्रॉब्लम्स इट इज वेरी इंपॉर्टेंट दैट यू लुक एट द इनपुट एरेस इन द लाइक ऑल द एग्जांपल्स दैट आर गिवन। In case if you are sitting in an interview and you don't have any input examples, it's always good to ask your interviewer for some some examples so that the question becomes more clear to you, right? Because like you only have limited time, so you can not go wrong in your interview. So it's better like you have certain examples so that you go in the right direction from the beginning. So let's take a look at this example. The first example says that we have a certain set of values 12, 3, 4, 1, 6, 9 and the sum is 24. So now if we look at the output, so the number set 12, 3 and 9 gives us a sum of 24. So this is the first set that satisfies our solution. It isn't mentioned here that there can be one or more solutions, so we are not considering that. Maybe like your interviewer can ask you to provide you all the subsets that are like giving this kind of sum, but right now the problem is not that one. Right now what we are dealing with is that we have to just return a boolean value true or false in case if the situation is satisfied or not. Let's take a look at the second example, which is wherein the input array is 1 2 3 4 5 and the output is 5 3 and 1. So this is the basic problem that we have. So now let's see like how we can solve this problem, right? So this is basically very widely known as the threesome problem. But to understand this problem, basically to solve this problem, you first need to understand the two-sum problem. So we'll start now with two-sum problem today, and then we'll build the intuition for threesome. So what does the two-sum problem says is that, say like let's take the same example 1 2 3 4 and 5, and say we have to find whether the array contains any subset of two numbers whose sum is equal to 9, right? So now if we take a look at this array, so we have a number, we have a set of 5 and 4 that satisfied the situation, right? So right now this array is in a sorted fashion. Let's rewrite this array, right, in an unsorted fashion, because one thing that you really need to understand is that in your interview, even if the interviewer is not mentioning that this is this will be a sorted array, you should not assume that it will be given as a sorted array to you. You have to like consider all the cases. So in that case, like the array can also be an unsorted one, right? So do not make assumption that because what you are seeing here is a sorted array, so the input set that your problem needs to deal with will definitely be always an sorted array, right? So considering that, let's rewrite this whole array with something like say 2 5 3 1 and 4, right? So now like say that this is our problem statement. This is our problem statement array, and we need to find a sum of 9, right? So now let's look at the very brute force algorithm first, right? How would you solve it? So if you look at the problem, a very basic approach would be that you just iterate through the whole array, figure out the set of two numbers such that they give you a sum of 9. So for example, like you will first consider the subset 2 comma 5, then 2 comma 3, then 2 comma 1, then 2 comma 4, then you'll move on to 5 comma 3, then 5 comma 1, then 5 comma 4, right? Then 3 comma 1 and 3 comma 4, then 1 comma 4. So these are all the subsets of your array, and this one satisfies your condition. So this is your solution, right? But in this case, you'll have to like iterate all the numbers because you don't know which one will satisfy your condition. So that is why you have to iterate through all the possible subsets to find out your solution, which means that your solution will work in like, it will take like n into n minus 1 iterations, which is equal to n square. So the time complexity of this algorithm would be n square. Let's also quickly write the program for this algorithm. So what will we do is that for I is equal to 1 or 0, I is equal to 0 to array length minus 2, Why minus 2? Because minus 1 will be using, like, will be covering the minus 1th element in the in the like the internal loop, the secondary loop. For j equal to 0 to array dot length minus 1, right? I'm writing a pseudocode so that you can easily adapt it to any of the coding language that you are using, right? So now you'll all that you'll have to do is that if target is equal to array of I plus array of j, then here you can just return 2. That's it. And if you don't have anything, like if you don't have any satisfying situation, so once you move out of this loop, you will return a false. So this is your brute force algorithm, and it works in O of n cube, or O of n square, right? Now let's take a look at an optimized solution, right? There is one more solution which you can do using hash map. You can explore that. We are not covering that in this video. We are covering another approach which is based on the like a sorted array. So let's see like how we can do that and see how we can like optimize this number now. So see, right now our input array was 25314. Right, so what we'll do is that we'll just like sort the array now. So after sorting, the array will become something like 1 2 3 4 and 5, right? Now say we want to find the sum of 9, right? So what we can do here is that rather than like iterating over the whole array to find out the subset which kind of from all the subsets, the possible subset that satisfy our solution, what we'll do is that we'll start from first element. We'll like take 2 pointers and we'll start from the first and the end. So right now, like, so now we'll just sum them up. So the sum now comes out to be 5 plus 1, which is equal to 6. So now, given that this is a sorted array, we know that 6, and if like our sum is less than 9, so what we need to do is that we need to move the first pointer towards the right, because we know that if we move the second pointer towards the left, with the sum will further reduce. But right now, because our current sum like 6 is less than 9, so we need to move this like the first pointer towards the right so that we can increase our result, right? So now in the next iteration, what we'll do is that this first pointer will move on to 2. Right now we'll check if 5 plus 2 is less, if is equal to 9, greater than 9 or less than 9. So 7, 5 plus 2 is 7, 7 is less than 9, so we'll again move it by 1 position. Now we'll again check 5 plus 3, is it 8? 8 is less than, still less than 9, we'll again move by 1 position. Now we get the sum 9, and that satisfies our answer, so we can return a true here, right? So now you can see the only iteration that we made, like the only number of elements that we had to traverse in this solution is the total number of elements that are present in an array. So the time complexity of this solution is O of n, because you're only iterating through the array once, right? Now let's take take another example. Let's think of it that we want to find out whether our array consists of some 7. Right, so first of all, we'll start with the first 2 elements. The first pointer and the last pointer are at like 1 and 5 respectively. So 5 plus 1 is equal to 6. 6 is less than 7. We move the first pointer by one position. Now 5 plus 2, 7. We directly get the answer. But let's say that we didn't had this 5. Probably we had this number as 15. Right, I actually want to cover that scenario wherein I'll also move the second pointer towards the left. So that is why let's now take this example. So our first pointer is at 1, the last pointer is at 15. 1 plus 15 is equal to 16. 16 is greater than 7. So what we'll do is that because now 16 is greater than 7, so what we'll do is that rather than now moving the first pointer, because we have got the sum which is more than our target sum, so we'll move the last pointer by -1 position. So now my last pointer will start pointing to 4, and now I'll check 4 plus 5, 4 plus 1. Is it greater than 7 or less than 7 or equal to 7? 4 plus 1 is 5. 5 is less than 7. So now what I'll do is that I'll I'll move my first pointer towards right by one position. So now my sum is 4 plus 2 and target is 7. So 6 is still less than 7. So I'll again move my first pointer by one position. Now 4 plus 3 is equal to 7 and we return true here. Right, a solution for the two sum problem. So it's very easy. The arguments that we are taking in our start, end, the complete array and the target sum, right? So as we said, the first thing that we have to do is like first sort this complete array, and then we'll move from start to end, and we'll check whether if the target is equal to the element of start plus end, will return true. Otherwise, if target is greater than start plus end, we'll do start plus plus, because what we are saying is that the target is already like more than the current value that we are getting. So we'll have to like move the first pointer towards the right so that we can get a bigger value in the next iteration. The only case that's now remaining is that if the target is less than the first the start and the end, in that case we'll have to like move our end by one element so that we can get a smaller we can get a smaller number, right? Now if all of these conditions are like done, and we are sure that we have like iterated from start to end but we are not getting any result, we'll move out of this loop and we'll return a false, right? Now there's one thing that you need to understand is that you always make sure that start is less than end and start is not less than or equal to end. Because if we'll do something like start is less than or equal to end, then think of it that, say if you're trying to find a sum of 10 and you have element 5 in your array, then potentially what will happen is that 5 plus 5 is equal will become 10, right? So which will give you a wrong result. So you have to like be very cautious about it, that iteration should only be from start is less than end, not the condition should not be something like start is less than or equal to end, right? So now the time complexity of this will be O of n log n, right? So now let's take a look at the code, right? So for this approach, so what we are saying here is that for int I is equal to 0 to array dot length minus 2 or length minus 3, because the last two elements will be covered in our internal array, right? So let's take a look at the parameter that we are passing first, and the first number, the second number, the array, the target, right? Now one thing that we'll also need here is the starting and the ending position, right? Int start and int end, because now we are not iterating the complete array in every iteration, right? So we'll not be like using these hard-coded values, because see, like right now, like we have seen that for the first iteration we are taking out 1 2 3 4 and 5, right? So I stays at this position. Now for my two sum, my start will be at this position and my end will be at this position, right? Now because I don't have any solution in this iteration, I'll again like move my I by 1, right? So in the next iteration my I will move here, right? Now I'll be running the two sum solution on these three elements of the array, right? So I cannot have a static value for start and end. The start and end also need to adjust. In fact, like end will still be like same, because end is always the end of the array, but my start is always something that is like changing, right? But why I'm saying so is that like you should be passing the values, because the interview can also ask you that what if I ask you the fourth sum problem. In that case probably you'll need another, like basically like you can like start one pointer from the beginning, one from the end, and you can start out like try to find the sum, the pending sum from the rest of the array, like from the first, like the second element to the n minus second element, and then third element to the n minus third element, right? So it is always good to like be explicit at the first place and try to pass the last number also in the method call, right? So now let's look at the solution, right? So what we are saying is there, if bool result is equal to find to sum, right? Because right now what we are saying is that I is already iterating from 0 to array dot length minus 3, right? So now the only thing is left is like to iterate over this subset of array, right? So this is where we are now running a two sum problem, right, with a reduced target. So let's see like how we'll be doing it. So our the first position will be I plus 1 comma a dot length minus 1, right? Now you may ask like, why should I still pass this value of like the ending value, because it is still static, like it is always array dot length minus 1. So do I still like need to pass this value? So I would say definitely you should be doing that, because say if your interviewer further extends this question for a four sum problem wherein you need to like put one pointer at the starting and one pointer at the end, and you need to like now iterate through the rest of the arrays, you will have to like keep squeezing the initial and the last pointer. So that is why like it's always good to be like thinking about how your code can be extended, right? So if right now if I wouldn't have taken this array dot length minus 1, then if the interviewer would have asked you like what will happen if you think of the four sum problem, so you'll have to again like modify your code and pass this last value, right? So that is why it's good to like pass the last index as well, right? So and then array and the target sum. Now this time it would not be target sum, it will be target sum minus array of I, because we'll now pass a reduced sum, right? We are not passing the complete sum, right? Now what we'll say is that if result is equal to or we don't even need this, right? What we can just write is that if result, then return result. Remember this thing, that you cannot like directly return the result here, because what would happen is that, like say like in the first iteration you don't find the solution, right? But in the subsequent ones you can find the solution. So if you are not writing this situation, if you are not writing this condition, your program will not iterate through the rest of the iterations. It will only iterate for the value of I is equal to 0, which will give you a wrong result, right? So that's the whole solution that we'll have to do. The time complexity of this solution will be O of n square. Feedback or any doubts on this question, feel free to post them in the comment section, and I would love to discuss them. And if you want me to solve any specific problem, please share that problem in the comments. I hope you like the solution. I hope you are able to understand the solution. If you're not able to understand, feel free to like leave a comment and let's discuss that, what was the trouble that you're getting. And I hope you'll keep learning. Thank you.